So you had asked some questions about how to calculate or how to do the hydrogen and hydroxide ion concentrations. So I'm going to go over that with you here real quick. So this slide is from the PowerPoint that is linked on the assignment page for Canvas. And so there's some slides before this and after this, but this will give you a quick rundown of hydrogen and hydroxide ion concentrations. Okay, so hopefully remember about pH. So pH scale ranges from 0 to 14. 7 is neutral. Anything below 7 is acidic. Anything above 7 is basic. Okay, so kind of have that idea in mind. And while we're thinking about the hydrogen and hydroxide ion concentrations, we're thinking about what goes on and what makes something have a different pH. So the pH is basically the relationship between the amount of hydrogen ions and the amount of hydroxide ions that are in a solution. Okay, so if something has a pH of 7, it's neutral. And it's neutral because the amount of hydrogen ions is equal to the amount of hydroxide ions. So if you look at this diagram here, they look pretty equal. If you look at the numbers here, they're also equal. We'll get back to the numbers in a minute. As something becomes more acidic, the amount of hydrogen ions increase, but at the same time, the hydroxide ions decrease. If something becomes more basic, the hydroxide ions increase, but the hydrogen ions decrease, okay? So there's this directly inverse relationship in any solution between the amount of hydrogen ions and the amount of hydroxide ions. And it has to do with the ability of water to dissociate. So if we take water, H2O, and break it up, you get hydrogen and hydroxide. Well, depending on how the solution allows that dissociation, it indicates the hydrogen and hydroxide ion concentrations. Okay, so the numbers. So this actually should say 1 times 10 to the negative 7th. So writing in scientific notation. So 1 times 10 to the negative 7th, remember the negative 7th is 7 decimal spots. So 1 times 10 to the negative 7th is 0.00000001. Okay, so a very small number. If we look at the exponents here, so if something has pH of 7, it has 1 times 10 to the negative 7th hydrogen ions. If something has a pH of 4, it has 1 times 10 to the negative 4th hydrogen ions. If something has a pH of 10, it has 1 times 10 to the negative 10th, 1 times 10 to the negative 14th or 14th. So hopefully you're seeing a pattern that this number is always the same as the pH. If we were talking about something with a pH of 2, its hydrogen ion concentration would be 1 times 10 to the negative 2nd. If we're talking about something that was a pH of 8, it would be 1 times 10 to the negative 8th, okay? So pH is basically a shorthand way to show the amount of hydrogen ions in a solution. All right, pH ranges from 0 to 14, and this inverse relationship basically adds up to that 14. So if you take 7 plus 7, that's 14. 4 plus 10, that's 14, okay? So if you know the hydrogen ion concentration, you know the pH. Actually, if you know the pH, you know the hydrogen ion concentration. If you know the hydrogen ion concentration, you know the hydroxide ion concentration. So if we look at these, they all add up to 14. So look at the hydrogen and hydroxide, they all add up to 14. So if you had something with a pH of 2, its hydrogen ion concentration would be 1 times 10 to the negative 2nd. Its hydroxide ion concentration would be much, much smaller, 1 times 10 to the negative 12th. But 2 and 12 equal 14. If we were to come up here and do a pH of 13, so if something had a pH of 13, its hydrogen ion concentration would be 1 times 10 to the negative 13th. Its hydroxide ion concentration would be 1 times 10 to the first, or 1 times 10 to the negative 1. Okay, so whatever the number here plus the number here should equal 14. And so basically that's how you do, we'll just do the simple version of pH. So on the activity, it asks you to pick things from the chart or the diagram that have different pHs, just use the whole numbers. Don't use like partial numbers. So if something has a pH of like 4.3, just call it 4. So you can round up or down to the nearest pH. You don't have to do the like 4.3 because then that it's a math thing and it becomes more complicated. I just want you to understand this inverse relationship. So if as pH goes down, you get a greater number of hydrogen ions. As pH goes up, you get a greater number of hydroxide ions. Okay, so if on the scale it has a pH of like 6.2, you would just call it 6. So if something has a pH of 6, its hydrogen ion concentrations would be 1 times 10 to the negative 6th. Its hydroxide ion concentration would be 1 times 10 to the negative 8th. So 6 plus 8, did I add that right? Yes, I did. Okay, 6 plus 8 is 14. Okay, hopefully that helps. If you have any questions, feel free to email me back, okay?